we're up. Okay, so let's go to... Okay, so what happens if the period of a sine or a cosine function has been changed, right? So we said that in the default case, the period of a sine or cosine is 2 pi. So it takes the length of a 2 pi for it to complete one cycle. But it could also change. How you find the period if you have the function given is with this. Period is 2 pi over b. So this is something you just have to memorize. Period is 2 pi over b, right? And the b, remember, is this, it's the coefficient of the x, right? So here we go. If we wanted to find the period of the given functions, we have sine of 2x. The coefficient of the x is your b. So period would be 2 pi over 2, which is just pi, right? In this case, cosine of 3x, b is 3, so it would just be 2 pi over 3. Now, if you wanted to write, 2/3 pi, that would work too. Either one of them is fine. Here we go. What's b in this case? We're going to leave that for later. What's b in this case? 1/2, right? So the period is going to be 2 pi over 1/2. And some people can just do this in their head. Some of us need to write it down. 2 pi divided by 1/2 is times the reciprocal 2 over 1. So that's just 4 pi. Right? So let's do another one of those. B is 1/5. So it's 2 pi divided by 1/5, which is 2 pi times 5 over 1, 10 pi. Okay, so in this problem D, right, what is the amplitude? 3. In D, the amplitude is 3. Okay? Okay, so here we go. Right here, I have sine of 0.25x, right? Okay, so that's going to be like, okay, so 2 pi over 0.25. That's not okay. We can't have a decimal inside a fraction. Right, but we know that 0.25 is 1/4. So this will just be 8 pi. Okay. Do not put all this in your calculator and do like 8 times pi and get like 26.3 or something, right? This is not what we're doing. We're leaving it in terms of pi. Okay, but now look at this one. B in this case, it's all of that, 3 pi. So the period is 2 pi over 3 pi, right? This is different because now you have another pi. The pi's cancel, so it's just 2/3, right? So when you have something like that, don't let that throw you off. It's okay. All right, so how do we graph one if we have something like that? Okay? All right, so take a look here. I have f of x and then g of x, right? So here, I want to write the period of g of x. It's going to be 2 pi over 1/2, which is 4 pi. That means instead of completing a cycle in 2 pi, it's going to take 4 pi to complete. Okay? All right, so now how are we going to graph this? Again, we're going to have an x-axis here, right? But now what we're going to do is we're going to set up an inequality, right? Remember how default sine and cosine went from 0 to 2 pi? I'm going to set up an inequality like that, from 0 to 2 pi, like this. Inside the inequality, I'm going to put all of this, the stuff that comes after the sign, half x. So now I have to multiply everything by 2 to get x alone. So this is 0, x, 4 pi. This is your graphing region, 0, less than or equal to x less than or equal to 4 pi. What this also will be, right, is the start and end of the new period. Okay? So, over here, same as before, I go from 0, 1, 2, 3, 4, but here I put the new ending, which is 4 pi, right? So you see how here I have 0 to 4 pi, 0 to 4 pi. Now, I need to come up with these other points. Each of them is a midpoint. There are 5, right? Each of them is the midpoint. So look at this red one. This is the midpoint between 0 and 4 pi. Halfway through them is how much? 2 pi. Oh my God, are you kidding me? Okay, 2 pi. So now take a look at this blue one. Halfway between 0 and 2 pi, 1 pi, or pi. And now this red one, halfway, 3 pi. All right, so now I've got my 4 points, right? Now, I'm going to go ahead and graph. All right, so let's put the y-axis here. Remember, we're graphing a sine. I start on the axis. The amplitude is 1. So I go up 1, 0, down 1, 0. And that's how that looks. Because it's in front of the sign there is a 1. It's 1 sine half x. Here, hang on.
So the signs, whatever is in front of the sign, or the...
Yeah, if there was something, there would be something else.
Wait, so it's gonna kind of look...
Hang on, there is a 1 here. You see that red 1? Okay. Yeah, what?
So it's gonna look the same.
Yeah, the points are different. So the way it looks, okay, if we had graphed sine x, right, it would have started and ended until 2 pi. So it kind of would have looked like this. This is f of x, right? This is how sine x looks. And then look at sine of half x. Look at it takes twice as long to complete, okay? So this now, between the black and the red, this would be playing a different note, right? So like the black would be, let's say, or if the purple is a middle C, the black would be like a little bit higher, like an octave or 2 higher, right? That's what it is. Okay. So let's take a look at this one. Now I have cosine 3x. The period is 2 pi over the b, which is 3. So 2 pi over 3 is the period. For the graphing region, again, I go between 0 and 2 pi. What am I going to put inside? 3x. Now, divide by 3 to get x alone. So I get 0 less than or equal to x less than or equal to 2 pi over 3. For now, until we change it. Okay, so here we go. Okay, 0, 1, 2, 3, 4. That's going to be a 2 pi over 3. Okay, now, so until now it's been really easy to get these midpoints, but let me show you how to do it if it's not immediately obvious to you, right? So look at this. This red one is halfway between 0 and 2 pi over 3. So back in the day, you learned that to find the midpoint of two things, you add them and you divide by 2, right? So to get that point, you're going to add 0 plus 2 pi over 3. Then you're going to divide by 2, which is like half times that, okay? So that will be half times 2 pi over 3, which is pi over 3. Okay, now, let's do the blue one here. This is how I do it. Watch. That blue point, look at what I do. It's halfway between 0 and pi over 3. So now that's half times pi over 3, which is how much? Pi over 6. Love it. Okay, this green one. Green one is halfway between pi over 3 and 2 pi over 3. So that's halfway to 3 pi over 3. How much is 3 pi over 3? 1 pi, right? So that's just pi over 2. Okay? You guys were saying, you didn't like you weren't doing real math. You know what? I'm here now. We're not doing that. I'm here now. This is what we're doing. This is what we're doing. We have a new class. This is what we're doing. Okay, so this is how we have to do it. We have to do it methodically. Okay, so, what else? What are we graphing here? Cosine. So cosine starts with 1, right? Cosine starts away from the axis here. Then we're going to go to 0, down, 0, up. And here we go. Okay? Questions? Okay. Ooh, look at this one. Now we have 2 cosine 2x. So take a look. This first 2 gives you the amplitude, right? So here, the amplitude is equal to 2. This second 2, that's your b. That's what we're going to use for the period. 2 pi over 2, which is pi. So my graphing region, right, we're going to go from 0 to 2 pi. I put 2x inside. Divide by 2, divide by 2, divide by 2. So 0, x, pi. Everybody okay with this? So 0 to pi. Okay. Exactly halfway point between 0 and pi, pi over 2. Now look. Exactly okay, so Rowan, I'm calling you. Halfway point between 0 and pi over 2, how much is this? Pi over 4. Fabulous. Okay, so this one is halfway between pi over 2 and pi. So that's halfway between pi over 2 and 2 pi over 2, which is 3 pi over 2. And then finally that becomes 3 pi over 4. Okay, now look, some people might just look at this and they're like, okay, pi over 4, pi over 2, 3 pi over 4 pi, like they might just see it. Or you might not, right? So always have a way out in case you forget or you can't think of it, right? And the process of how we do it is having the way out. Okay. Yeah.
I'm kind of confused what you did in the green.
Okay, so let's go with the y-axis here. Okay, so the period is 2x here, but the amplitude is also 2. So I'm going to go up to 2, 0, down to negative 2, 0, and then up here. Okay, so here we go. Okay, so use your pencil, right? And, get in touch with your artistic side. And, I have little to no artistic side, but, just you got to do a sketch, right? Don't add extra curves because then you technically haven't graphed a cosine. You've graphed something else. Okay. All right, so that's how we do period. Now, frequency is the opposite, or it's the reciprocal of period, right? So imagine if you're like at the beach, right? And like you're standing up at the shore and like the waves are coming and hitting you. How frequently, right? The waves hit you, that's the frequency. Okay, boom, 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 boom. Huh? It's time. It's like it's not time. It's within a given second how many waves pass by you, right? So if you're standing there, it's like oh my god, like I was just hit by like, 4 waves in the last like 2 minutes, right? That's what it's like. And so now imagine if you are being hit by the waves very frequently like that, then each of the waves is a short wave, right? It's like, so it's got a shorter period. Whereas if you get hit by a wave and then you have to wait a really long time for another one to come, that means each of the waves is a much longer wave with a much longer frequency. Okay, I'm sorry, a much longer period. Okay, so here is how you find the period and the frequency. So the period, right, in this case, it's sine of 1x, so b is 1. So the period is 2 pi over 1, which is 2 pi. This is the period. The frequency is the reciprocal of this. So it's 1 over 2 pi. Now look, you're allowed to have pi in the denominator, right? Some students are not sure. They're like, oh my God, really? Am I really allowed to do that? So, they'll put it like somewhere here. So it's like, it's like you can't tell, right? It's like it could either be down there or up there. No, you don't get credit for that, right? You got to be bold with your pi. Put it down in the denominator if it belongs in the denominator. All right, take a look at this one. B is 4. So period is 2 pi over 4, pi over 2. How much is the frequency? 2 over pi. Okay? All right, phase shift. Phase shift is when it's like a horizontal transformation, right? Phase shift moves the graph horizontally either left or right. Okay, so let's take a look at what we're doing here. Look at this one, 2 sine of blah, 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 right? So let's find all of the required information. Okay, amplitude is this number 2. Period. The coefficient in front of the x is b. In this case, it's 1. So 2 pi over 1, 2 pi. Frequency, 1 over 2 pi. For the phase shift, you have to do some work. You're going to take this thing inside the parentheses, x minus pi, and you're going to set it equal to 0. How do I solve for x now? What do I do? Add pi. So x is pi. That is your phase shift. X is pi means the whole graph has moved to the right pi units. So now we're no longer going to start from 0 anymore. So let's see what the graphing region is going to be. We're going to go from 0 to 2 pi again. Always 0 to 2 pi. This time, we're going to put x minus pi inside of here. So now, to solve for this, I add pi. So I get pi x 3 pi. Aha. So now this is the beginning, and this is the end. So let's go here. Well, the period was already changed, right? You'll see now what's going to happen. So here we go. We're going to go from pi, 1, 2, 3, 4, to 3 pi. Okay? Now, we have to find this middle. So what's the middle between pi and 3 pi? So let's see, it's halfway between pi and 3 pi. So that's half of 4 pi, 2 pi. Okay, let's find this blue. So halfway between pi and 2 pi, half of 3 pi, 3 pi over 2. Let's do the blue one, the green one. Half of 2 pi plus 3 pi, 5 pi over 2. Okay. Is 0 one of these points? No, so we're not going to put a y-axis. All right? So we're graphing a sine with an amplitude of 2. So here I go up to 0, down to 0. And here we go. Huh? Oh my God. Is your mic on? Your mic isn't on, is it? Okay, last one. Oh, look at this one. Look at how pretty this function is. All right, what's the amplitude here? 4. Oh, period. Okay, so look, this, right? X over 2, that's the same as half x, right? So period is 2 pi over a half, 4 pi. Frequency, 1 over 4 pi. Okay, phase shift. We're going to do some work for phase shift. Remember? X over 2 plus pi over 3 equals 0. Subtract pi over 3. X over 2 equals negative pi over 3. What do I multiply by? 2. So x is negative 2 pi over 3. Okay, so let's see what the graphing region is. 0 to 2 pi. X over 2 plus pi over 3. Okay, so we're going to subtract pi over 3. By the way, you can use your calculator for this part. So we get negative pi over 3, x over 2, and then here I have 2 pi minus pi over 3, right? If you want to put it in your calculator and do like 2 minus 1 over 3 just with the coefficients, you can. Huh? 5 pi over 3. 5 pi over 3. Because this will be like, so it's 2 pi minus pi over 3. And then you remember you have to multiply by 3.
Oh, I did it.
6 pi minus 1 pi. So 5 pi over 3. So here we go. Oh, times 2. So negative 2 pi over 3. Yeah, to what? 10 pi over 3. Ooh, love it. Okay. Negative 2 pi over 3. 1, 2, 3, 4, 10 pi over 3. Oh my God, I love it. Okay. So here we go. Look. Halfway between negative 2 pi over 3, 10 pi over 3. Halfway of 8 pi over 3, that's 4 pi over 3. Here. Halfway of negative 2 pi over 3, 4 pi over 3. Halfway, negative 2 plus 4, 2. And then look, these 2's cancel, so it's just pi over 3. And then the last one is halfway, 4 pi over 3 plus 10 pi over 3. Half of 14 pi over 3. And the 14 and the 2 become a 7, so that's 7 pi over 3. This is really like the hardest, like not the hardest, but the more like arduous part. And then the rest is just fun graphing. So again, there is no zero that is, unless the 0 is one of your 5 points, don't bother with a y-axis, okay? But now this is a cosine with an amplitude of 4, 1, 2, 3, 4. Fine, but you gotta like somehow tell me. See, if there's no y-axis, it's hard. Okay, I'm okay. Wait, hang on. 1, 2, 3, 4, 0, 4. All right. Look at that. Oh my gosh, how beautiful is that? Look at that. Look at all of this math we've done today, right? Like, that's amazing. This is super, super